Oscar's been a good dog, so Tobin gives him the treat. Good dog, Oscar! Oscar's been trained to stand on his hind legs while he is receiving the treat. Tobin notices that each of the two footprints Oscar made while standing on two legs are deeper than the ones each foot made when he was standing on all four legs. Explain why this should be. Well, this is a pressure question. So we know that pressure equals force divided by area. We know that the weight force of the dog, the good boy Oscar, is constant. We know that because gravity is constant and the mass of Oscar is also constant. And so when Oscar stands on his 2 feet, his total area in contact with the ground is halved, because he used to have 4 paws in contact with the ground. Now he's only got 2, and we assume his paws are the same area. So that means his area is about halved. And so because if area is halved and force is the same, that means that pressure must have gone up. And so the pressure is doubled. And so if we answer the question, that means that the greater the pressure, the deeper the footprints. And so that's what we have. We have more pressure because there is less area for the same force. B. Oscar meets a doggy friend who is much larger and far more solid dog with larger paws. Together they walk along the beach for a short distance, and Olive notices that the footprints left in the sand by Oscar's friend are much deeper than those left by Oscar. Explain why Oscar's friend's footprints are deeper than Oscar's footprints. Okay, so Oscar's mate is larger. That means she has more mass. From F equals ma, or mass times gravity, and gravity is constant, she's got more mass. That means she also has a larger weight force. Now, we know that pressure equals force divided by area, and so if we increase the force, then we are increasing the pressure. So there is more pressure. So we also know that the higher the pressure, the deeper the footprints in the sand. Okay, so that's pretty much a good answer. More massive dog, more force, more pressure, deeper in the sand. However, we notice up here in the question, it also says she has larger paws. Okay, so if she's got larger paws, that means she has larger surface area. And so that decreases the pressure. That does the complete opposite. So if she has huge paws, if she's got big snowshoes running down the beach, then she won't sink very much at all. So it does the opposite of having more force. So that means that her weight force must be much bigger than the difference between her paw size. So as Oscar's mate made deeper footprints, the difference between their paw surface areas must be less significant than the difference in their weight. So Oscar must be a skinny dog, and Oscar's mate must be quite a big dog, and they must have about the same size paws, but Oscar's mate has slightly bigger ones because she has made deeper footprints in the sand. So we needed to link both of the ideas of footprint size and weight in order to be able to get the excellence for this question. Question C. Oscar decides he has done enough running around for a while, and so he lies down on the sand for a rest. Oscar's mass is 4.5 kilograms, and when he is lying down, the area of his body in contact with the sand is 0.3 meters squared. Calculate the average pressure Oscar exerts on the sand. Well, we know that pressure is force divided by area. We know that force equals mass times gravity. We've been told that his mass is 4.5 kg, and on the front cover we know that gravity is 10, so there is 45 newtons of force. And so the force is 45 newtons, and we've been told in the question here that the area is 0.30 meters. And so we can simply type that into our calculator. We can go 45 divided by 0.3, and we get 150 pascals, capital P, lowercase a. D. While Oscar has been lying down, his friend has been playing with another dog. Oscar decides to join them and accelerates away from his rest position until he reaches a constant speed. Describe and compare the horizontal forces that are acting on Oscar when he's lying down, when he is accelerating, and while he is traveling at a constant speed. So in I, he has a reaction force and he has a weight force, and these are equal and opposite. Now, you'll notice that it doesn't actually talk about vertical forces, it's only asking for horizontal. So what's happening horizontally? Well, nothing really. His net force is 0. His weight force equals his support force, and there are no horizontal forces. Okay, well, how about while he is accelerating? Well, in order for him to accelerate, he must have a thrust force, And because it'll be colliding with air and there'll be other sort of friction forces, we'll call that a drag force. But his thrust force must be larger than his drag force in order for him to be accelerating. So we can say he is accelerating, so there must be a net force in the direction that he's accelerating in, i.e. that his thrust force must be larger than his drag force, which is opposing his motion. Okay, well let's have a look at the third case, while he's travelling at a constant speed. Well, at a constant speed, his thrust must be equal and opposite to his drag. And so these will have little dashes on them to say that they are the same size. If we were to put that in words, Oscar is now travelling at a constant speed, so his net force is 0 newtons. That is, his horizontal thrust force is equal and opposite to his drag force. If you just say equal to, that means that the drag force is actually pointing in the same direction, and so he'll be accelerating. So without that word opposite, your answer is wrong. Okay, so that's the sort of thing that we're looking for. So essentially there's no sideways forces in I. The thrust force is larger than the drag force because he's speeding up, and then where he's at equilibrium, the thrust and drag are equal and opposite.